Now, as I told you, I'm just going to take certain codes from MATLAB help. So I have just stored it. If you just open your MATLAB online and just type this, you'll be able to get all these things. So it will automatically go to the MATLAB window. So here what I'm doing is I'm just going to enhance the multispectral color composite image. Okay. So it's a live editor. So we can run and see. So what is the ultimate objective of this is we are going to read the multispectral data from ERDA's LAN files, and we are going to construct the different color composites. Like if you take multispectral data, you're going to have different bands. So it's going to just compare different band information. You're going to enhance the image with contrast stretch application as well as decorrelation stretch application. Like what is correlation? As you all know, it shows a relationship between the pixels. How much the pixels are correlated with each other. So similarly here, different bands, it will have correlation. So before applying the correlation stretch, how the image is going to be, and after applying correlation stretch, how the image is going to be. We are going to visualize that. So I'm going to run each and every section. So here we are first reading the multiband image. See here, hope I'm sharing the screen. You're able to see, no? Yes, if you visualize in MATLAB, it will be better. So this is how my unenhanced images. As you know, it's a satellite imagery. So it's a multispectral image in which it contains. I cannot expand it further. This is the full size. Okay. And next, this is unenhanced image. Okay. So if we go for image histogram and see what is the red band. So we'll run this section. So this is the histogram of red band. Again, as I told you now, it is just occupying the lower portion of the image. Next, what I'm doing is I'm just getting the red component, green component, and blue component. Okay, here a true color, it's a 512 cross 512 image. If you want to extract, as you know, RGB image, the first component is red. If you want to extract red, you have to give it as 1. For extracting green, you have to give 2, and for extracting blue band, you have to give 3. So scattering plot, like if you're having one more plot, which is called scatter plot, which will give the information of all the 3 bands in a single structure. So from that, you will find how much correlated the output is going to be. Let us run this section. So this is the scatter plot. It shows all the 3 bands are correlated with each other. So this is my red band, this is my green band, and this is my blue band. So it's very clear, like all the 3 bands are correlated with each other. Okay. So we want to perform some decorrelation stretch, and like we want to increase the contrast and also decrease the correlation between those 2 bands. For that, we are going for contrast stretching and correlation stretching. So the first thing what I'm doing is I'm just adjusting using im_adjust function. And for contrast stretching, there is a function called stretch limit. So we are just going to stretch your contrast. For that, we are using stretch limit function. See how better the image is now. You are able to see all the fine details present in the image after contrast stretching. Okay. And again, I'm going to just check the histogram after performing contrast stretching. Now only I told you we need to use im_hist function. See how the histogram is. It has spreaded for the entire range of gray level between 0 and 250. So this is what your histogram equalization will do. Okay. And next is, as I told you, From the scatter graph, it's very clear. It's having correlation. We want to reduce the correlation by using decorrelation stretch. So I'm just using decorrelation stretch function. See how beautiful the image is now. In this way, again, you can check the correlation by plotting the scatter plot. See here, it has span, it has increased, it is increasing the correlation. So from this, it's very clear by applying simple enhancement, combination of enhancement techniques, you'll be able to do wonders in case of image enhancement. Okay, so this is a practical example, and I'm planning to show barcode identification and a simple image classification technique. With that, we'll close today's session. From me, after that, Kalyani madam will be like continuing. Any doubts in this? Like, it's very simple code only, and I'm trying to give it as clear as possible. If you have any doubts, please let us know. The ultimate objective is whatever we are teaching, even if it is small content, it has to reach you. So the thing is, what I'm interested in giving you is, in case of image enhancement, you just don't stop with one technique. You apply with combination of techniques and try to get the result whatever you are interested in. Okay, so here it's a multispectral image in which it's a very, very important application. So many researchers are still going on in this hyperspectral and multispectral imagery, in which you'll be able to find where the water content is present, because it's an image taken from the satellite, and it will cover a wide area. It's not possible for us to do the analysis manually. So only through image processing it's possible. For that, we need to have a clear clear-cut idea of that image. For that, the first and foremost thing they'll do is like doing certain image processing techniques.